going to do two more examples today, all right? Same stuff. We're finding the equations of the inverse, and we're taking a look at the graphs of the function and its inverse. So this is example 4 out of the book. It says, find an equation of the inverse function of f of x equals the square root of x minus 2. Step 1 in the process is to rewrite the function as an equation. And that simply means replace the f of x with a y. The second step is to switch the x and the y. So it becomes x equals the square root of y minus 2. So the third step we know is to solve for y. To get rid of the square root, we have to square both sides. Now let's use blue. So I'm going to square that, and I'm going to square this. The square and the square root will undo each other, leaving us with y minus 2 equals x squared. And we finish this off by adding 2 to the left side, so we get y equals x squared plus 2. All right, so we have solved for the equation of the inverse. But now let's investigate the graphs a little bit more. We know from the previous lesson that the graphs should reflect across the line y equals x. So let's pull out our calculators and graph these. We are going to graph the original function right here as y1 on the calculator. We are going to graph our inverse, which is what we found down here, as y2. And we are going to graph the line y equals x because that's the line that these two graphs should reflect across. And we want to be able to see that on our calculator. Okay, so let's plug those in. So I have my 3 equations. The first one, the square root of x minus 2, that's the original function. y2 is x squared plus 2. That's my inverse. And y3 is y equals x. That's the line they reflect across. Now I'm going to graph one at a time. I'm going to start with y1 only. You can see that y1 has the equal sign that's darkened. It's only going to graph that one. So I'm going to do zoom 6, and there's the graph. Right? Now we should be familiar with this graph. The square root of x minus 2 is the square root graph shifted 2 units to the right. And that's exactly what we're seeing here. See that value right there, x equals 2? That's shifted 2 units to the right. This is a function because it passes the vertical line test. And we know that its inverse will be a function because it passes the horizontal line test. Talked about this in the previous lesson. If a horizontal line, an imaginary horizontal line, touches that graph at only one point, then that tells us that its inverse will pass the vertical line test and be a function. Okay? So now, let's bring in that inverse. Go back here. Let's turn this on. And let's graph both of these because we want to see this line y equals x2. Okay, now there's a little bit of craziness going on here. The original graph was supposed to reflect across the line y equals x. And that would have given us this piece only, right? What is happening here is the domain of this graph, this square root of x minus 2, when we solve for the inverse, we get the quadratic. And the calculator is going to graph the entire quadratic, including this piece over here. But we really don't want that piece. Because of the domain of our original function, the blue graph, is restricted from, let me erase this. It starts here at x equals 2 and gets more positive. When we reflect it across, we're going to go from here and just graph that piece. So this piece here, we really can ignore. But your calculator doesn't know that. Your calculator is just going to graph it as the entire function. So that's a little bit confusing, but you need to understand what you are seeing whenever you graph those. All right, so this is part B. So we're going to do the same thing. We're going to find the equation of the inverse, and then we'll check out the graphs. Step 1, rewrite the function in equation form. So it becomes y equals negative cube root of 4x. Step 2, switch the x and the y. This becomes x equals negative cube root of 4y. Let me rewrite that. That negative sign is just in a bad place. Negative the cube root of 4y. That's much better. Now we need to solve for y. Step 3, right? Well, to undo the cubed root right here, we know we have to cube both sides. So that's what we're going to do. Put this whole thing, let me just rewrite it. The whole thing will be in parentheses and will be cubed. And if we cube that side, then we have to cube this side also. Now we know that the cubed root will be undone by the cubed. But let's pay attention to that negative sign also, right? This whole thing is negative. When we cube something, that means we multiply it by itself 3 times. So that means we have a negative times a negative times a negative. Well, a negative times a negative is a positive, but then a positive times a negative is a negative again. So the result here is a negative 4y, and that equals x cubed. So to finish solving for y, we're going to divide both sides by the negative 4 on the right, and we're going to get y equals x cubed over negative 4. And if we wanted to, we could write this in function notation, and this is probably important to say. Instead of saying y equals, we would say the inverse of f of x equals x cubed over negative 4. We're going to graph the original function as y1. We're going to graph the inverse as y2, and then we want to graph the line y equals x as y3, because we know that's the line that they will reflect across. So I've entered the original function as y1, the inverse as y2, and y equals x as y3. Zoom 6. And there's my graph, right? The blue graph is the original function. The red graph is the inverse. Take a look. I'll sort of trace them here in green. See this part of the blue function? It's reflected right here on the red function. See how those are mirror images of each other? And then we have this part of the blue graph and this part of the red function. Those are also mirror images of each other. So we're confirming that the original function and the inverse will reflect across that line y equals x.